You often see different kinds of graphs in the newspaper, magazine articles and whatnot having to do with the display of statistical information. And graphs can be extremely effective in giving us information very, very quickly. It gives us an idea of comparative numbers probably more than anything else. It's a quick way of comparing things. Now, graphs have these characteristics. They all will have some kind of title. There'll be a scale of one kind or another, and there'll be labels on whatever scale that we're talking about, and a lot of times the source of information is given as well. Well, the first kind of graph we're going to talk about is a bar graph, and with bar graphs, and you've seen them before I'm sure, but the bars can either be vertical or horizontal. That's important to know. But the bars should be of uniform width, and the distance between the bars should be uniform. That is, the bars should be uniformly spaced. Now, the length of the bar in bar graphs gives an illustration of some kind of quantity. And it's a comparison of the lengths of the bars that make the bar graph so very effective. Let's build a bar graph concerning rainfall amounts in inches in Honolulu, Hawaii. These are average rainfall amounts in Honolulu. I have a month here, rainfall amount in inches here, and let's build the bar graph for this information. You see, a lot of times we might want to very quickly, well, we'll see what the bar graph can do for us when we look at it. Looking at these figures, it might not tell us very much. Then again, it might tell us the same thing as the bar graph does, but it might take longer to interpret a list kind of like this. So, to build a bar graph, and I've already built a bar graph, but when I began to build the bar graph, I wrote the label for the bar graph up here. That's one component that's important to realize. And then I knew that I needed two axes. One axis that had to do with the rainfall in inches, and another axis having to do with the months, or the time situation. So on this axis I'm writing the rainfall in inches, and notice the labeling here, and notice the 1 through 5, and we're starting at 0 on this axis. That's kind of an important matter, that we start with some basis, and usually it's 0 on the axis. And on the time axis I have January, February, March, April, and so on. Now the bars, the lengths of the bars represents different amounts of rainfall from month to month. And notice this, the width of the bars is even all the way across, and the distance between the bars is the same all the way across as well. And from this we're noticing that, gee, we have kind of a downward trend from the first of the year. We have a downward trend, and it's in the summer months basically that the least amount of rainfall will occur, and then starts to ramp back up as the winter comes on, as we get into fall and winter. So if we were deciding when to go to Hawaii, we might decide to go in a month of lesser rainfall, so we might choose one of these months. Not that this amount of rainfall is such a great deal. Even the high months in Honolulu is not a great deal of rain. Well, there is a way with bar graphs, for bar graphs to be misleading, and they can either be deliberately misleading or not deliberately misleading. But a way of causing a bar graph to be misleading is to sort of lop off part of the graph and sort of forget that it's there. Now, here's the graph of unemployment rates in the United States over several months in some previous year. So unemployment rates. Now, down at the bottom are the various months over which the information is given. It's September through February. And on the left side axis there's a percent associated with the unemployment. Okay, now in reading this and interpreting it at the top of the graph, we're noticing that the unemployment rates are between 10% and 11%, and they don't fluctuate a great deal up here. The unemployment rises a little bit in this particular month. It happens to be December, and then falls back down in these 2 months, but it's not a big deal. However, it is possible to restructure this so that it's rather misleading. And you might be led to think that this is okay because, after all, the values that are down in this part of the graph aren't used here. It's only all the action is between 10 and 11%. So why don't we make the graph like that? Well, look at what happens to our interpretation if we structure it that way. Here's 10%, here's 11%, here are these same unemployment rates, September through February. Now, these are just the tops then of the bars on the previous bar graph. And if we were going to interpret this, we would say, gee, from September to October, oh my, the unemployment rate doubled from September to October. You see, and that kind of thing. And oh, gee, we dropped off a great deal here. So the sort of comparative nature of the bar graph is lost when part of an axis is truncated like this. Now this is flatly false. This is a wrong way to structure a bar graph. Now sometimes it is necessary to lop off part of a bar graph, sometimes. But if that's done, an indicator like this needs to be used. If on this bar graph we were starting at 10%, then we really should start the graph a little bit down here and actually make a notation kind of like this, where we have a little indicator that says there's a break in the action here. And now our months would go this way, and all of these month indicators would be below this line. But at any rate, there would be some kind of designation like this, indicating that there is a break from this low point of 0% to this position of 10%. And anytime you see a break like this in either axis, it's a warning bell should go off and say, ding, 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 there may be a problem with this graph. Before we leave the topic of bar graphs, I'd like to show you a rather sophisticated bar graph just for the purpose of interpretation. It's one thing to make a bar graph, it's another thing to interpret it. And just for interpretation purposes, let's have a look at this one. Notice this is a bar graph of United States music sales from the years 1986 through 1990. And the first thing we might notice about a bar graph like this that involves multiple colors is a key. And the color key is telling us that green stands for compact discs, CDs, red is record albums, and yellow is cassettes. And we'll notice that on our graph, notice how the yellow items are sort of peaking at the top of the graph. Those are cassettes. And the green items are increasing rather dramatically. Those are CDs. And record albums are decreasing during this time period. And that's really what makes this time period so interesting in United States music sales, because of the decrease in the record albums during that period. Well, in looking at a graph like this, oh, and notice that on the left vertical axis is the number of these items sold in millions. Now, we can answer certain questions in a graph like this. The first question might be something like, in the bar graph above, the difference in millions between the number of CDs sold and the number of cassettes sold in the year 1987 was, and we have various choices. Now, notice that it says 1987, and we're comparing CDs with cassettes. So we would go back to the graph, we would identify the particular year, 1987, we would look at the green and the yellow, that's the CDs and the cassettes, and then our attention would be turned to the left side, the vertical axis, and we would be looking at the difference between these two levels, you see. So we're thinking about the difference between 100 million, 400 million, gee, that's about 300 million, so we would make the selection for 300 million. Let's answer a couple more questions. What about the increase in millions in the number of CDs sold from 1987 to 1988? 1987 to 1988. Now we're only talking CDs, so we're thinking about the greens, you see, so those are the columns where we look, the bars that we look at, and then again our attention goes over to the left and we look at the difference between these two. It looks like a difference of about 50 million. So we look from the bottom, you see, to the top of a bar, and then we look over to the left. Now consider this one, the decrease in millions in the number of record albums sold from 1986 to 1989. and we want to know what that decrease is. Well, we'll notice that the record albums are the items in red, and we notice a general trending down throughout this period in record albums. But very specifically for our question, we're talking about the 1986 to 1989. We're talking about that decrease. So we look over here to the left, and we're looking at the difference between those two black arrows there as our answer. And that's the whole idea, that we start kind of at the bottom, we look up to the top of a particular chart, and our interest goes to the left-hand vertical axis to notice differences. A special kind of bar graph is called a Pareto chart. And Pareto charts have the characteristic that the bars are arranged according to height. Now, this is particularly useful, and Pareto charts can come into play when the lower axis is not some kind of timeline, for example, where we have to list the lower axis in a particular fashion. And Pareto charts are useful in being able to identify the most frequently occurring items or the least frequently occurring items in a particular survey. Let's say, just as an example, let's think about a survey that involves the causes of lateness to school. And we'll list causes in one column and frequency in another column. And let's say that this survey was taken over a few months, and that more than one cause may be used for each occurrence of lateness. But at any rate, these are the results of the survey. Snoozing after the alarm goes off occurred 15 times. And car trouble occurred 5 times. And there are a number of other causes, and let's say that these are those other causes, and these are the frequencies associated with them. Now notice taking too long over breakfast occurred 13 times. Last minute studying occurred 20 times. Finding something to wear, dressing, delayed us 8 times. Talking too long with roommates 9 times. And other items occurred 3 times. Now the other, with a frequency of 3, probably means that there were 3 items, 3 different causes that only had a frequency of 1. So they were put into one lump, one category called other. And the total of those would be 3. And it's probably the case that there were 3 different items that occurred only once, and they were lumped into one cause. Okay, so when we make our Pareto chart, we're going to identify the cause that occurred the most frequently. And that would be the last minute studying. So we would list that as the first bar in the bar graph in the Pareto chart. And then we would identify the next most frequently occurring item, and that would be snoozing after the alarm goes off for 15, and so on down the line, so that the Pareto chart then looks like this. And we can very quickly then identify that studying was the greatest cause of lateness to school, and that the least number of lateness occurrences occurred from car trouble. Now the other means that there were some 3 insignificant items that were lumped into one, but the ones that are identifiable, the car trouble occurred least often. Okay, another kind of graph that's particularly interesting is pictograms. And notice that here we have a pictogram of sales of homes in Orange County, California from the years 1991 to 1995. At the bottom of the chart, notice that it is indicating to us that each of these little pictures of a house represents 600 homes. That's kind of the nature of a pictogram. Now, pictograms are used to emphasize the topic being related as well as the quantities. So here we have pictures of houses, which is indicating, you see it's a little visual idea of what the topic is that we're talking about, as well as the quantities that are associated with that topic. One situation involved with pictograms that's important to realize is that pictures should all be the same size. There's a tendency sometimes that when there is a greater frequency to make the pictures bigger. For 1991, for example, compared to 1992, we might think, well, let's just make a bigger house. Well, that's not really appropriate, and it's a rather misleading use of a pictogram to use just larger pictures, so we don't do that. Let's think about interpretation here. Suppose we want to tell how many houses were sold in Orange County, California in the year 1993. Well, we would look at that level on the pictogram and we would sort of think, well, we have 4 complete houses and half of another one. The 4 complete houses, each one of those pictures represents 600 homes. So 600 times 4, gee, that's 2,400. And then a half a house would be 300 homes. So 2,400 and 300, gee, that's 2,700 houses sold in that year in Orange County, California. You see, that's the interpretation for that line of the pictogram. Now let's say that we want to discover or talk about the difference in the sales of homes from 1991 to 1992. The differences. Well, we notice that both of the lines in 1991 and 1992 have 3 whole houses. So that's the way that they are the same. And the difference in the number of sales of homes would be this part that's sticking out in 1991. And so it's 1 whole house plus almost another whole house. So each house now represents 600 homes. So it would be something a little bit less than 1,200 homes, maybe 1,100 or perhaps 1,000 homes as the difference in housing starts or sales of homes in Orange County, California for those 2 years. Another type of graph that we want to talk about would be circle graphs. Circle graphs are also called pie charts. Sometimes they're called pie graphs, but at any rate they have the particular characteristics that they are useful to help in understanding percents or parts of a whole, and we can identify those percents or parts of a whole very quickly using circle graphs. Let's have a look at a particular one in a particular problem. Here's the problem. Our emphasis here is going to be in making the circle graph rather than interpretation. Interpretation is rather simple. It's almost obvious. But so we're going to concentrate on making the graph associated with this problem. Problem says, where do you think you use the most water in the home? According to National Wildlife Magazine, the percent of water used in different parts of the home is as follows. The toilet, 40%. Shower or bath, 20%. Bathroom sink, 15%. Laundry, 12%. Kitchen, 10%. And outside use, 3%. Now notice that these are in a particular order. They don't have to be in any particular order, but they happen to be for this list. Now let's talk about how we would begin to structure our circle graph. We would obviously begin with a circle, and we think about a radius of the circle. We're going to try to manufacture areas of this circle corresponding with the percents that we looked at just a moment ago. So we have to have some kind of beginning point. A radius like this is a good beginning point, and then we're going to turn some angle from this point, and the angle corresponds with an area. Now how do we turn that angle? How do we make the areas that we're interested in? One way would be to do this. We know the first item in the list was the toilet of 40%. We know that all of the angles, or excuse me, the measure of the entire circle is 360 degrees. 40% of 360 degrees we could calculate to be 144 degrees. We could turn an angle of 144 degrees then to associate with the toilet use. There's another way though when percents are used that might be a little more effective, a little more quick for us to use in those circumstances where we're dealing with percents. Think about identifying points on opposite sides of the circle like this. And now think about the semicircle above and below those points. And in the semicircle above those 2 marks, subdivide that semicircle into 5 parts like this. Just think about little arcs of equal length, and think about 5 of them and make marks associated with those differences. So the marks might look like this. See, we've identified the upper semicircle or subdivided into 5 parts. Same way with the bottom semicircle. Now once we've finished with this process, we have subdivided the circle into 10 arcs of equal length. So each of the arcs would represent 10% of the entire circumference. And if we're talking about little pieces of the pie from the center, a little slice between the arcs would be 10%, you see, of the area of the circle. So when we want to identify 40%, we just turn this angle all the way over 1, 2, 3, 4 of the little marks, and that represents 40% then of the circle, and we label that 40% of the water use is for the toilet. Now, one thing I am leaving out here is a labeling of the overall circle graph. I should have a label for the circle graph that's appropriate, but in the interest of space, I'm making the circle as big as possible, so I've left that out, but I want you to know that I've left that out. At any rate, the next item on the list was the shower bath at 20%. 20% would be 2 of these marks, so we turn an angle, you know, of 2 of the marks, and that represents 20%, and we make our labeling of 20% for the shower and the bath. The next item is 15% for the bathroom sink. Now, 15% would be 1 entire little slice of the pie plus a half of the next one. So the next angle that we turn is for 1 1/2 of these marks, and we label this as the bathroom sink. Now, it gets a little more tricky when we have turned an angle and the angle is between marks. Now, this one is right in the middle of a couple of marks, and we know that one segment or one of those little sections is 10%, so the little leftover part here is 5%. Anyway, the next item on the list is the laundry for 12%, so we have to guesstimate just a little bit. We've got 5% for the remainder of this mark, and we go a little bit more than half in the next segment, and so this then would be the mark for the laundry at 12%. Now, it gets especially tricky now when the items get pretty small. The next 2 items are the kitchen for 10% and the outside for 3%. And instead of going from the last mark that we made, it might be more convenient to turn an angle from the beginning, you see, down for 1 segment below, kind of like this, and make that the area corresponding with the kitchen. So we would mark this for the kitchen, and the leftover part here is the part marked for the outside at 3%. So we have completed now our circle graph. Another kind of graph we want to look at is called a time plot. And time plots show data measurements in time order. And they allow us to make certain interpretations that are more difficult if we're just looking at a chart. For example, here's a chart of a particular problem, and these are distances in miles that we might be walking or jogging in 30 minutes. Now notice this chart involves weeks 1 through 20, so we're making a chart over a 20-week period, and this is the total distance over each of those weeks. We just want to see what the trends are. Now, maybe by studying this chart, we can notice the trends from the beginning weeks to the ending weeks and see that rather clearly, but it takes a little longer to see it in chart form than it would by using a time plot. Now, to make a time plot, this is just almost like a regular, ordinary, everyday household graph, you see, because we'll begin by making a first quadrant kind of graph. We'll label one axis with the weeks, see, 1 through 20, and then on the other axis we're labeling the distance, and the distance is in miles. And all we do is plot the information from the chart from before. So for week 1, 2, 3, and so on, we just go through, make a dot for each one of those distances for each one of the weeks. And then once we're finished making the dots, we connect the dots left to right with segments. And now you see the beauty of this is that very, very quickly we can notice this upward trend in the distance covered from week to week. Now, we can't extrapolate from this and interpret this as meaning, well, gee, if we continue this kind of pattern, then maybe in 50 or 60 more weeks we'll be up to 50 miles per week. No, we can't do that. We can just say that during this time period, you know, we increase the amount of distance rather dramatically from the first few weeks to the last few weeks, and we seem to be improving as we go along. That's the kind of interpretation that would easily be made and very quickly be made from a time plot.